In this problem, it says a resort plans to apportion 47 new toboggans, so I'm going to circle that 47, among the 4 resorts based on the number of rooms in each resort as shown below. So we have Resort A has 94 rooms, B has 103, C has 131, and D has 272 rooms. And there's a total of 600 rooms. We want to determine each resort's apportionment using Jefferson's method. And as a hint, they say use a divisor between 12 and 13. So if the divisor that I need to use is going to be between 12 and 13, I'm going to start with 12.5, and we'll see if that works. We don't know. Okay, so I'm going to enlarge this a little bit. And we do have one other resort down here. So I'm going to write Resort D, and then how many toboggans. Okay, so if I'm dividing by 12.5, and we had 94 rooms for Resort A, I take 94 divided by 12.5, and I get 7.52. And then B is 103, and I divide and I get 8.24, and I'm just rounding all of these to 2 decimal places. That'll be fine. And Resort C has 103 rooms, and so we get 10.48 when we take 131 divided by 12.5. And then finally, Resort D has 272 rooms. So when we divide that by 12.5, we get 21.76. Okay. Because we're using Jefferson's method says to always go down to the previous whole number. So when we have 7.52 here, I have 2 choices for what the final divisor should, or the final quota should be. So my choices are 7, we have 7.52, and then 8. So which way do we go? With Jefferson, we always go in this direction. If it was Adams, we'd always be going up to the next integer. And if it were Webster, then we would round normally. So in this case, if it was Webster, we'd also be going up. But because it's Jefferson, we're going down. Whoa. Okay, well, let's just erase all of that. And we're just going to say this becomes 7. So I really just need to lose the decimal portion. And then I do the same thing here because we're going down to 8. This goes down to 10, and this goes down to 21. So I'm going to add those results together, and hopefully it adds up to 47, and then we're done. So 7 plus 8 is 15, plus 10 is 25, plus 21 is unfortunately 46, and we don't quite have enough toboggans handed out. So 12.5 doesn't work. Because we need to have more toboggans, we need these numbers to be larger. We actually need one of them to be 1 larger. So what I'm going to do is I'm going to divide by a smaller number, because dividing by a smaller number is going to make the result larger. So really, if you can't decide, am I supposed to go smaller or larger, just try both and see which one works. So I am going to go with 12, and then if the numbers get too large, then we'll go somewhere in the middle of 12 and 12.5. Okay, so now I'm going to take 94 divided by 12, and that gives me 7.83. And 103 divided by 12 gives me 8.58. And 131 is going to give me 10.92. And finally, 272 divided by 12 gives me 22.60. Bring that back. 22.67. Okay, so now, again, I'm going to say that's 7, that's 8, that's 10. Even though it's so close to 11, it doesn't matter. We always go down because that's the way Jefferson did it. And then 22.67 goes down to 22. And I can see that's one more. The other numbers are all the same. So this is going to add up to 47, which is what we want. So we have 7 for A, 8 for B, 10 for C, and D will be 22 because they have so many rooms. And that's how you do that problem with Jefferson's method.